Okay, hi guys. This is new for you. You're watching a video of me and you're at home. I get it. You miss me, but you'll be fine. You can do this, okay? The only thing that's going to be a little different is I've already pre-written these notes out, so you may have to pause the video and copy down the definition into your notes and then listen to me explain it, okay? But we are going to talk about a very major thing today called hypothesis testing. Very, very important. You are doing this in your project, your final project. You have to do a hypothesis test. So what is hypothesis testing? What is a statistical hypothesis? So it is a conjecture about a population's parameter. And again, if you don't remember what parameter is, your most common parameter is mean or standard deviation. We can even look at percents. But what we're looking to see is whether or not a claim is true. A claim may or may not be true. And that's what your whole final project is going to be about. You're getting some research right now. You're developing something. You found a statistic, something that said 23% of the population believe that, believe in what's the one I always use? Aliens, space aliens. Okay. Well, that's may or may not be true. Let's find that out. Okay. So there are two things that you are going to put down in terms of your hypothesis. One is called the null hypothesis. The symbol for it is H sub O, okay? The other one is an alternate hypothesis. Let me write this down. And the symbol for that is H sub A. But some books have it differently, but this is how I'm going to do it. The null hypothesis means there is no difference between the two parameters. There's nothing. It's the same, okay? 23% of the population? Yep. When I did my research sample, I got 23% of the population believing in aliens, okay? This is always, always, always an equal sign. Always, always, always use an equal sign. For alternate hypothesis, there is a difference, interesting, between the parameters. So the symbols we're going to use would be not equal, less than, or greater than. Okay. And then I want you to understand what happens when you have a two-tailed test, a right-tailed test, and a left-tailed test. Okay. And we'll get into this in a minute, but if you end up having a two-tailed test where you're looking at what we call the two tails, these are your two tails right here. The way you would write your HO and your HA, and I'm just going to choose mean. I'm just going to use mean. You would write your mean is equal to some number, let's say 23. And then your HA would be, for a two-tailed test, well, it's not equal to 23, okay? These two right here have to be what we call mathematical opposites. All right. If I have a right-tailed test, my picture is going to look like this. My region will be right here that I'm concerning myself about. And this is what it looks like. You're claiming your HA is actually, your mu is going to be greater than, I will say, 15. I think my mean is greater than 15. The mathematical opposite for that would be mu is then less than or equal to 15. Always got to have an equal in your HO. And then for a left-tailed test, you're concerning yourself about this kind of region. And let's say I'm making a claim that my mean, my average for grades on my final exam are I don't know, less than 80%, okay? So I would shade this way. My null hypothesis would be, no, they're equaling about 80, okay? And then one more thing just to talk about before we actually do some examples are what I just was drawing, what are called critical values. These regions that are in the red right here, these red regions, okay? What are they? They're these cutoff values that define the region where a test statistic it's unlikely to lie there, but it might lie there. And even when you do your project, it might end up there. If that does happen, then we get to reject the HO, which we're going to talk more and more about. But today, your focus is on just stating a null and alternate hypothesis and finding critical values. That's all we're doing today. So hopefully you've taken out this sheet right here, which is your homework sheet. Sorry for the purple. And it says steps in hypothesis testing, examples 8.1. Okay, so let's work out a few of these together and hopefully you'll see the pattern. It's not that hard. You always think it's hard in the beginning and it's not hard. A researcher studies gambling in young people. She thinks those who gamble spend more than $30 a day. She thinks, this is her claim, okay? So you have an HO and you have an HA. Your claim goes here in HA, the alternate hypothesis. If I think young people gamble and they spend more than $30 a day, so I think their average is more than $30. What would be my null hypothesis? Well, I think they're actually spending about 30 bucks. Okay? This is a right-tailed test, just so you know. You don't have to draw it now, but I just want you to understand. How do I know it's right-tailed? Because they're spending more than. So I'm looking to see if anything falls in this region, which we'll get to in a minute. Let's do number 2. A researcher wishes to see if the police officers whose spouses work in law enforcement have a lower score on work stress questionnaire than the average score of 120. The researcher's looking to see if they have a lower score. The researcher is claiming they might have a lower score. So that's my HA. The researcher thinks the average is lower, less than what? 120. That's his claim. All right, then the HO would be, it equals 120. All right, could you put greater than or equal to? You could, okay? You could put greater than or equal to. I usually always keep it equal in the HO. All right, number 3. A teacher feels using an online textbook for a course instead of a hard book may change the student's score on a test. In the past, the average score was on the final was 83%. What is she claiming then? If they change the student's score on a test, change it what? Is it lower? Well, that's a change. Is it greater than 83? Well, that's a change. So how do I write this? Well, you just write mu is not equal to 83% or average. What's the alternate? That's the alternate. That's the claim. The null hypothesis. Well, we're saying no. It is. It's equal to 83%. That's the average. Okay. So that's the first part of your homework tonight. You just got to do an HO, HA, null hypothesis, alternate hypothesis. Okay. And by the way, this second one I didn't draw it for you, but this was a left-tailed test. How do I know it's left-tailed? Look at this HA right here. It's less than left. This HA is not equal to what kind of two-tailed, I just said it. What test is this? This is a two-tailed test. All right. Last couple of things here. Use a calculator to find the critical values for each situation. Draw a normal distribution showing the critical region. Okay, so you haven't done this in a while, but I know you remember how to do this. If we want a left-tailed test with, this is an alpha symbol of 10% or 10, that means I'm going to draw my normal curve. I want it left. I want it on the left. And I want this region to be 10%. So I want to find the critical value, meaning I want to find the Z. Oh, we've done this before. It's been a while, but we have. How do I find this Z right here? It's very easy. On your calculator, you use inverse norm. How do we put this in again? So turn this on. You go to, second vars, number 3, which is inverse norm. You always start from the left. So our area that we're concerning about on the left is 10.10%. Keep your mu at 0, your standard deviation at 1, and negative 1.28. So 0.1001, just so you remember. But the Z is the critical value I'm concerning about, negative 1.28. That's my cutoff value. If I land in this region, I'm going to reject my HO. If I don't and I land over here, I'm good. Okay? We'll talk more about that. Let's do a two-tailed test. Two-tailed is always different. Two-tailed meaning with an alpha of 0.02. Does that mean this is 0.02 and this is 0.02? No. That means together they're 0.02. That means this is 0.01 and this is 0.01. Okay? So I need to find the Z values here. Well, you really just have to find one. So you, second vars, inverse norm, 0.01, just up to here. And I get negative 2.32. And guess what that one is? Yes, positive 2.32. Good job, Lance. I know some of you are saying, I said it too. I know, you're brilliant, children. All right, let's do one more. Right-tailed test. Let's draw that. It's going to look like this. You're going to be shading right. Okay. And this region right here is 0.0005. Oh, actually, I kind of drew that terrible. I should draw it much tinier because 0.005 is really tiny. All right, now remember this. You cannot put 0.005 in your calculator. No, no, no. Your calculator only goes from here to here, from in the left region. So what is this left region here? That would be 1 minus 0.005, which is 0.995. That's what you're going to inverse norm. 0.99501. And you will get this right here to be 2.58. Your Z is 2.58, okay? Now, what are these called again? These numbers are critical values. We're going to look for them, okay? These critical values, you need to find them. All right, last but not least, steps in hypothesis testing. These are the 5 steps you're going to do every time when we start doing an actual test. And I want you to write them down. First things first, state your null and alternate hypothesis. Identify the claim. Usually just write HA is your claim, okay? Step number 2, you state the significance level that you're using. You're going to choose your own significance level in your project. And you want to find critical values, those Z's, okay? So significance level, what is that? That is your alpha, okay? Critical values, that is your Z, okay? Number 3, you're going to compute a test statistic with your own research. Okay, so you're going to compute a test statistic. We'll get more into what that is. We're going to create our own Z or a T Or to be honest with you, toward the end, we do a p-value because I like this, and you create this on the calculator. Calc. Step number 4, you then make a decision to reject your HO or fail to reject. These are very important words. We'll get into this next topic, but this is literally what you say. You don't say, I accept the HO. You actually just say, I failed to reject. Very weird words, but this is how we use it in statistics. And last but not least, number 5, we're going to summarize the results. Okay? Try these problems out tonight. You can do it. I have faith in you. All right? Bye.